Okay, let's dive right into this. Welcome to the Explainer. Today, we're unpacking a truly groundbreaking piece of AI research. It's called UNIEGO. Yeah, UNIEGO, which stands for Unified Egocentric Video Representation Learning. I know, that sounds like a total mouthful, but don't worry, we're going to break it down step by step. Essentially, we're looking at how to make an AI understand the world exactly the way we do, through a single first-person camera view. But, and here's the kicker, giving it the brainpower of an entire team of outside experts.
So here's our roadmap for today. First, the wearable camera problem. Second, the multi-teacher dilemma. Third, Level 1 proxy learning. Then, Level 2 selective distillation. And finally, we'll look at UNIEGO's final grade. Let's get to it.
Section 1. The wearable camera problem. Seeing the world from one narrow angle. All right, imagine trying to learn how to play a fast-paced sport, but you're only allowed to look through a paper towel tube. Crazy, right? Well, that is literally the fundamental challenge of egocentric or wearable cameras. Take a look at the egocentric camera view on the left here. This is what a person wearing smart glasses actually sees. You catch a glimpse of hands, maybe an object, but what on earth is the rest of the body doing? The actor's own hands actually cause what's called self-occlusion, basically blocking the view. Now shift your attention to the right side, the exocentric skeleton view. This third-person perspective maps out the entire geometric structure of the human motion. It's like a giant puzzle, and the wearable camera on the left completely misses this vast amount of physical context.
And then we see a very similar limitation when we compare standard color video to depth perception. On the left, we've got your standard RGB video, red, green, blue color pixels coming from the wearable camera. It's essentially flat. But over on the right, we see the geometric depth view, represented by that awesome heat map. This shows the actual 3D structure and the distance of objects and limbs. Standard wearable cameras usually just capture those flat pixels, entirely discarding the crucial geometric structure of human motion that depth sensors provide. Without that depth, a standalone egocentric AI model really struggles. It doesn't know how close objects are or the true shape of a room. It leaves it fundamentally limited.
Section 2. The multi-teacher dilemma. A noisy classroom of AI models.
So, since our single wearable camera is blind to so much information, researchers naturally thought, hey, why not teach our egocentric AI using other AI models? Ones that actually do understand depth and third-person views. This is what the paper calls the naive multi-teacher approach. The idea makes sense on the surface. Feed the student AI data from 9 different expert teacher models that cover all those ego and exo viewpoints. But there's a huge problem. These models use completely incompatible architectures. Imagine the student sitting in a classroom being yelled at by 9 different teachers simultaneously, and each teacher is speaking a completely different language. In machine learning, this chaos causes representational gaps and conflicting gradient signals. The AI gets totally confused and honestly just fails to learn effectively.
Now, what's really interesting about this slide is how it maps out exactly how UNIEGO solves this headache. Look closely at panel A on the far left. This is that naive multi-teacher distillation we were just talking about. You've got different teachers throwing totally different data formats directly at a single student model. Total chaos. Panel B shows what this looks like mathematically in the AI's loss landscape. See that red star? That represents the student's learning parameter. It's literally being pulled in completely different directions by those red arrows, which represent conflicting gradient updates from teachers like the EXO-VIT, which, by the way, stands for Vision Transformer, a specific type of image processing architecture. Now let's look at panel C. This is where UNIEGO's hierarchical framework comes in to save the day. Instead of shooting directly at the student, the teachers pass their knowledge to a pool of proxies. And finally, in panel D, check out the black dashed arrows. They show the proxies shifting all that diverse teacher knowledge into a single unified proxy space, that green box right there. Now the student model, our little red star, only has to follow one clear unified red arrow. It's an absolutely crucial difference.
Section 3. Level 1. Proxy learning. Hiring the translators.
Let's move to the framework and see how this builds. To fix that noisy classroom problem, the hierarchical distillation framework is broken down into 2 clear, easily digestible steps. Step 1 is proxy learning. This is where we translate all that diverse, incompatible knowledge from the teachers into a homogeneous, unified space. Step 2 is selective proxy distillation. This acts like a filter for this newly translated knowledge to ensure our student only gets the most reliable supervision. Let's zoom in on step 1.
So what exactly is a proxy model? Think of them as specialized, highly trained private tutors. They're intermediary models that share the exact same architecture as the student. Their main gig? To translate diverse teacher knowledge into a homogeneous space.
That just means they convert all those different data formats into one single standardized format that the student model can easily understand. Because the proxy operates on the exact same egocentric video format as the student natively speaks, it effectively diminishes that nasty representational gap we talked about.
And these proxies have an immense translation job. Just look at this table detailing the 9 diverse teachers used in this framework. We've got RGB models like Dino V2 and Siglip. These are massive state-of-the-art vision models trained to deeply understand flat color images. Then we have Depth Anything, which is a model specifically built to calculate 3D distance. And on top of that, we have multiple exocentric skeleton models. The proxies are absorbing a massive amount of data from these foundation models and translating it, condensing it all down perfectly so our single wearable camera AI can actually make sense of it.
Section 4, Level 2, Selective Distillation, Tuning out the noise.
Okay, so now we have our proxy translators set up. But this raises a very logical question. What happens if one of our new tutors is just, well, flat out wrong about a specific video clip? You don't want the student learning bad habits, right? That brings us to selective proxy distillation, or SPD. This is an adaptive distillation stage that only selects the subset of proxies that are both correct and confident for each individual training sample. It doesn't just average all the proxies together blindly. Instead, it dynamically evaluates the tutors instance by instance, routing the supervision perfectly for every single video.
So the crucial point here is how this filtering mechanism actually does its job. For every single video sample, SPD evaluates proxy reliability. First, it asks a simple question. Did the proxy correctly classify the action? If the answer is yes, it then checks, okay, but is the proxy highly confident in its prediction? The student then distills exclusively from the reliable subset of proxies that actually pass these tests. It completely suppresses the erroneous signals. Bottom line, it ensures the student only learns from tutors who are absolutely certain they have the correct answer for that specific problem. No guessing allowed.
Now, before we even start that final distillation, the researchers use a brilliantly clever stabilization technique called proxy merging. They initialize the UNIEGO student model as a learned convex combination of the proxy parameters. Okay, actually scratch that. Let me translate. I know that sounds incredibly heavy. Essentially, instead of starting the student totally from scratch, they mathematically blend the brains of the proxies together to give the student its starting point. This places the unified model in a well-conditioned, flat region of the lost landscape. It's kind of like giving the student a massive head start on a flat, easy track before the final, most difficult exam begins. It stabilizes the whole shebang.
Section 5, UNIEGO's Final Grade, State-of-the-Art Results.
To see exactly how well this wildly complex setup performed, take a look at this alignment heat map showing centered kernel alignment or CKA scores. Think of this as a correlation matrix that tells us how mathematically similar two different AI models are. On the vertical axis, we have our original highly diverse teachers. On the horizontal axis, we have our corresponding egocentric proxy models. Notice that brilliant diagonal line of bright yellow and orange squares? Those high scores mathematically prove a one-to-one match. The proxies successfully translated the diverse signals from their specific teachers right into the unified egocentric space. For example, the complex graph-structured exoskeleton data correlates perfectly with the exoskeletal proxy. It is hard, undeniable evidence that level 1 of their framework worked exactly as intended. It's a real game changer.
And the real-world performance metrics are just staggering. UNIEGO completely outperforms naive multi-teacher baselines, achieving state-of-the-art results across 3 extremely challenging benchmarks. It excels in action recognition, so identifying what a person is doing. It crushes video retrieval, finding specific moments in long footage. And it dominates action segmentation, breaking down a long task into individual steps. But here is the absolute most surprising fact. This massive knowledge transfer works even on highly compact, lightweight models with as few as 22 million parameters. You don't need some massive supercomputer to run the final model. All the heavy lifting is done during training, leaving us with a highly efficient, incredibly smart student model ready for inference.
So, what does all this mean? Which leads us to our final provocative thought. What does a unified egocentric model actually mean for the future of augmented reality and robotics? Just imagine a robot assistant or a pair of smart glasses that only has a single standard camera lens. But because of UNIEGO, that system knows more than it sees. It understands 3D depth. It can infer the human skeleton. It grasps third-person context, all from that one single narrow video feed. That is a massive leap forward for deploying truly intelligent, capable AI out here in the physical world. Thank you so much for joining us on this explainer, and we'll catch you next time as we continue to unpack the future of technology.